So hello everyone and welcome to July 9 webinar. To start, I will explain what's the program of today's webinar. So first, the opening will be 5 minutes long. Then we'll be hearing at different projects from different competitors. So first, the project BETL001 will be explained, then ClassMind, and finally IrisBot. So today's evangelist, my name is Shimon Maniburu. I'm working at RoboMaker and currently interning at D-Robotics. I'm also part of the challenge, and my project is VigiBot powered by RDK. So VigiBot is an interface to control in real time your robot remotely around the world. And the objective will be to record data for future training. It will be capable of SLAM and integrate AI model in local. So just a quick reminder about the challenge. We are in the stage 3 and it will end in July 15. So you have a little time left to finish your project. And the award and closing will be in July 23. So first we'll be hearing at Rusted Friend. You can follow him in YouTube and Instagram. I'll be sharing all the information. Then we'll be hearing at Naren. You can follow him in LinkedIn and his project ClassMind. And finally, IrisBot by Vishal. So if you have questions through the webinar, do not hesitate to post them in the chat, and we will have 10 minutes at the end to reply them. And let's start with the first project by Rusted Friends.
Oh, I do have an unmute button. Hello, I'm Isaac. I am working on this. Well, I guess you guys can hear me, right?
Yeah, we can hear you.
So I'm working on my project that is called Beetle, which since the RDK challenge or the Robotic Dream Keeper challenge was specifically for using the the BPU on the RDK X5. I figured I'd make a dumb acronym, so it's BPU Education, Transport, and LiDAR, because the goal is for me to learn how to use the BPU, and then have basically just a little robot that initially will have a LiDAR scanner and a little roof rack to kind of carry stuff around. But be modular so that as I learn, I can modify it and change it and upgrade it. Let's see, share my screen. So actually, I should move my Zoom over here so that I can see what I'm doing. And okay, so I kind of went through a bunch of iterations on different ideas. I knew I wanted it to be roughly beetle shaped. Otherwise, the name doesn't make sense. And kind of take some inspiration from like the original Xbox and the way it was clear green, and you could see all the electronics through it. Hopefully, I can get most of this done in the next 6 days or whatever before the thing is over. Um, right now, I have kind of a bunch of parts of the physical build, but um, I got started a little bit later than I wanted to on the electronics. Let's see. So I also haven't finished all my CAD models, but it will generally look like this when it's done. If my computer will open my file. Almost. There we go. So I've got, I initially also thought it was going to be a lot smaller. I've got a bunch of, I took apart like 60 hoverboards and have all the motors and motor drivers. So I was scaling it around basically hoverboard wheels. But then once I started, these are batteries for an electric lawnmower that we've got. And once I realized I wanted to fit those batteries inside, I had to scale it up. And then it's just gotten bigger and bigger. But at least right now, if I stop sharing in its current state, let's see if I can click on myself so I can see what I'm doing. I've got like kind of all the electronics bolted to just kind of a prototype board with one battery instead of the pair. And then I've got my RDK on top. E-stop that is very needed because it's already constantly trying to crash into things. And then right now I've got it so that the ROS stack is subscribed to a node that, or a publishing node that either my laptop or my Steam Deck puts out for just manual control. So I've got right now I just have a joystick for, oh, I have to start my node. There we go. And currently it's just skid steer, but I already hate the skid steer and want to figure out how to make it actually like have a swerve drive or turn or something. But I think I'm going to be able to finish up the electronics in the next like day or two and then start welding the frame together and then bending acrylic to make it actually look cool and not just be stuff bolted to an old cutting board. But I think it should be a good robot when it's done. Let's see. And I know that was way less than 15 minutes, but if anybody has any questions, I can answer them.
I have a question. Can you hear me?
Yeah.
So you are going to drive it manually, or you are planning to add some mapping so that you can do navigation automatically?
Some of both. My goal is to have it build a point cloud as it's scanning. So my wife went to college for architecture, and I had originally built this little robot that never worked years ago. But the goal of it was to have it do LiDAR scan. It's got a LiDAR scanner on top that I was like, oh, you can just like let this loose to get measurements of the insides of buildings and things. So this is kind of the spiritual successor to that one. Voice and be able to like answer questions and at least do kind of simple conversation. I do think it's more endearing and kind of funnier if it's a little bit dumb. So it'll probably be like toddler level conversation. Any other questions from anybody? Um, in the chat, he said, "Did you have fun developing on the RDK X5?" And yeah, as far as like using the RDK compared to like I've done a little bit, like a few projects with like Raspberry Pis and other single board computers. I really like both the way it's laid out with its ports and like kind of it just feels easier to work with. And then I also really enjoyed using RDK Studio. Like the IDE for it is just makes a lot of things easier, especially with being able to just have a network interface over USB-C so that you can plug it in and then use that to do like remote desktop or just load files onto it or whatever. And then yes, it is currently working on ROS 2. That was the next question. Right now, it's just like one super simple, really just that one subscription to the joystick publishing, but the goal is to have it do a lot more because I've been kind of learning a bunch over the last couple of years about ROS 2 and machine learning stuff. So this is like the project to then give me an outlet to test out things as I learn them. I'm not those are all my socials. I'm not super active on any of them, but I always aspire to be more. I just never get around to it. I've filmed a couple videos throughout the process of this that I was hoping to have edited and posted already, but they'll probably get posted after it's done because right now I'm crunch time making robots.
Very well. So thank you very much to have shared your project. It was very interesting. We can now have the intervention of Naren, maybe. Naren, are you here? Are you ready?
Yes, yes, I'm ready. Firstly, congratulations, Isaac, and it was so great project. And I really aim to make like this project. And your garage is looking so pretty cool.
Thank you.
Uh, hello, everybody. I'm Narendra from Triple IT Nagpur, India. I'm in third year pursuing BTech in Electronics and Communication and specialization in IoT. So today I'm here to present the ClassMind. So I will be sharing the PPT with you. Is PPT visible?
Yes, it's visible.
Okay. So today I'm here to present the ClassMind, a smart classroom intelligence system. I want to clear beforehand that this is not a complete project, but my learning journey and what I learned. So what I learned, where I failed, and what I learned about this board during the journey. So I will be sharing with you. Firstly, I will tell you the problem I'm going to solve. This is the simple problem. The In every classroom and in every day, every teacher in classroom spends 4 to 5 minutes in taking the attendance manually by calling one by one roll number. And also after the class, when everyone goes out of the room, the lights and fans remains on until someone notice and turn it off. So this is complete waste of energy and also time. There are solutions solving these both problems, but there are separate solutions. So I thought, why not one age AI system can solve both the issues? So there are two goals of my project, that taking attendance under 20 seconds without any manual effort and also without any zero teacher interaction, and also take controlling the fans and the lights according to the occupancy of the room. So now I will share what happened when I got the board first time in my hand. So first of all, thank you to the D-Robotics team that they provided me the board when I was struggling getting the board, and also the budget constraint. They provided me the board within that with one promise that I will complete this project. Uh, so what I discovered and where I made the mistake, as I recently learned about the computer vision, about the YOLO. So I run pip install Ultralytics on it, but it simply runs on the CPU, not on the BPU, it will run on CPU. So later I took the help of the community and also read the document, and I got to know about the RDK model zoo, that it had compiled models, .bin models that runs on the BPU. It is also having YOLO model on it. So I used its runtime, and it made very easy to use on the model of the BPU. And this is the RDK Studio software. It has everything on single dashboard, the status of your board, what's its temperature, and how much percentage our CPU and BPU is getting used, and remote desktop option, terminal option, everything on one dashboard, which makes the development more easy. So this is also great about this. So what happened when first time I run BPU on the board? I was I got surprised that in 13 to 15 milliseconds, it was detecting a person. Means I use the Droid cam, means mobile camera as a camera through Droid cam over Wi-Fi. So capturing the frame and detecting a person in 13 to 15 milliseconds, it was so great, and I got amazed that how this means this board can do this much things. So I got to know about the real power of the AI, means AI accelerator, the power of real AI accelerator. So detecting a person was not only my goal, the who the person is, means face recognition was the target of mine. So uh, selecting the specific model mm, was also a task for me. So tested first I tested deep, which took 19 to 20 seconds for detecting a single person's face. Means recognizing single person face, which is completely impractical, and it was running on CPU. So it was impractical for me for classroom attendance, means for 40 to 50 students, it will take near about 15 to 20 minutes. It's not practical. Then I moved to S-space model, means deep space F-space model. It was taking 2 to 3 seconds, but accuracy was very less for the attendance system. So I moved towards the this inside face inside face buffalo S model, which was lightweight and also giving the best result for my project, that 1.5 seconds, and with cosine similarity, and was giving also accuracy was also good for the project. So these are some terminal screenshots that I got when I used DeepFace. It recognized that 90% confidence, but the time it was taking was 20 seconds per lookup. Then this is the complete architecture. Uh, as I'm not currently, I don't have USB camera also, and my Pi, I will get I'm going to buy a MyPy camera for this for deployment. So I use the Droid Cam. So while I use Droid Cam, it only allows one client at a time. And as I'm using occupancy pipeline continuously, and when need, I use attendance pipeline. So then, when the both were clashing, the Droid Cam was getting crashed. So I used a single thread consuming the frames and sharing these frames with the both pipeline. For occupancy pipeline, I used YOLO for person detection and controlling the lights and fans to the relay, I mean ESP32, then relay module. For attendance pipeline, I used a YOLO, means cropping that frame of that person, and then that that frame goes to the inside face. Means inside face don't use whole camera frame, it uses the person's frame. It computes on the person's frame. It decreases the CPU consumption and also saves the time. And then it goes to attendance CSV, and also teacher can see the attendance on the website like this. So I'm going to show you the live demo I captured now. As I'm at home, I took my help of my father and mother for this. So this is a website. Teacher has to put the classroom subject and classroom and duration 20 seconds. Then live camera feed is visible here. That here Datta Prabhu and Jyoti is present. And also you can see for now I didn't use the relay module. I used the inbuilt LED of the ESP32 for controlling lights and fans, for showing the control of lights and fan. So as my mother and father goes out of the camera, means out of the classroom, so this light will get off. And also the result will be visible on the website, but while recording, I didn't, means I forgot to show that. Result will also will be visible on the website that Datta Prabhu and Jyoti is present, means who the present. And what two real engineering problems we solved. So there are droid cam issues when I faced. I was seeing why it is getting crashed. So I solved by creating a single shared thread, and it was managing and sharing both. And also when I used a deepest module, it was allocating 411 MB. So it was, and I had only 800 MB free. So OEM was killing the process. And when I was using Flask in debug mode, so it was creating duplicate process and consuming my CPU, and also because of that also the Linux was killing the process. Then I used lightweight models inside face and also Flask in a non-debug mode. And for now, what's the current status and what's the next stage I will go to? So now I validated YOLO on BPU. It was running perfectly, and inside face on the CPU, and Flask teacher control means CSV and all that live feed on the website, ESP32 control through the RDK and shared camera manager. And what's next stage? I'm aiming to go to the MyPy camera for deployment. Relay module means real relay means to control real fans and lights. And scale testing means for now I had tested max till 5 to 8 people at a time. But when I will go to the hostel, means at my college, I will test with 30 students. Then I want to scale it to the 50 students for the real deployment. And I also want to go to the ROS, means to incorporate ROS2 in it for communication purpose. And then face recognition. I want, means now the face recognition is running on CPU, so taking a lot of time. So I want to go to the BPU, means made that model BPU compatible as the last workshop focused on that topic, that how we can make the BPU our model compatible to the BPU. And what key takeaways we can take, that RDK X5 BPU is very powerful for edge AI development, but you have to make your model compatible with that BPU, and there is documentation you can make it. And right model selection matters, not the hardware, means which model and what the purpose of the model for what it matters. And by creating projects, you get to know about new problems and you debug it, not only learning theory. So create projects and take work on the board, then you will face new problems and you will solve it. And once again, thank you to the D-Robotics for giving me this opportunity and also providing me the board. And also thanks to the Lisa, Evelyn, and Shockley for clearing our technical doubts. And the community was so active that every technical doubts was getting solved. And also the weekly workshops were also helping so much. So thank you so much to the D-Robotics for this platform. Thank you once.
Okay, thank you very much, Naren. So maybe Vishal, you can start your presentation.
Yes, sir. Hi, everyone. Hi, Lisa, ma'am. This is Vishal Kumar Bharti, electronics and communication student. I am a fourth year student, and since 4 5 years before, I too much learning about Arduino like uh, microcontrollers, and recently I got this. And this is my first single board computer, and I learned from it too much. And first let's see its working, then we will talk on its programming and how I made everything. And this is visible.
Yes.
Okay. So this is my Sahayak robot. Basically, I made this robot for helping me, for just study, and sometime if I'll become ill, then it will help me so much. It can call my parents. It can handle some social media also, and it can handle my room again, room light and fan, just giving a command. And here I made a remote wave control remote, and simply just forward and backward from here, and wait and here temperature and distance both it's giving in real time. And in this I use two mode, first online mode and second offline mode. In offline mode I used everything about this brain processor BPU. And here, as you can see, it's showing real time. Just a moment. Here, it's showing real time. It's working on directly on BPU, not any AI working. And in this, I used LLM, VLM, and command. And fully, I tried to make this autonomous mode. And let's check once. So here, just if I'll ask, just a moment. What is this? What is this? What is this? it has a check my room. Find my water bottle. Find my water bottle. Find my water bottle. Find my water bottle. Okay. This working on offline, and it has also follow me mode. It's working on real time, and here not I am using any AI for this, and it has a guard mode and guard mode. Just if someone come in my room, then it will alert me. Just nothing. And patrol mode, uh, it it's just seeing everything, and in last it will tell me what things have in my room, and this all about offline mode. And if you I will talk about in online mode, then here this is my favorite. Here I using a Gemini for vision model, and okay, find my RDK X5 board. Find my RDK X board. Find my RDK X board. Describe what is this. Describe what is this. Describe what is this. Okay. Find my Arduino UNO Q board. find my RDK X5 board. Find my Radza QB-A7 board. Find my Radza QB-A7 board. Can you describe anything? Can you describe anything? Okay. What is this? What is this? What is this? Can you define what is this? Can you define what is this? Can you find my Arduino UNO board? It's so this function is currently why not proper working, I don't know, and still I have to work on it, and sorry for the proper not working. And I'll talk about its software. I here used so many software and so many files here. Sorry, files I used. The main files here I used server.py. This is the main file. Here I not used ROS2. Just I used ROS2 for node graph, and I used here a Flask server for controlling everything. And I also voice command here I used, and voice backup, and voice backup just for uh, for just it YOLO add we have 18, it can find 18 parameters. So for that only I used backup only. And also server working backup, and here I'd audio breeze. This is all about software, and benchmark for its BPU, current BPU monitoring, and measuring also, and camera for just everything. Here I used this smartphone for camera vision only, and how I connected this camera from my RDK X5 using just a IP webcam. And before this IP webcam, I was used one another software that is Termax, but that was some different app, and that was not working properly. That's why I shifted on IP webcam. From IP webcam, this robot can see and detect anything, and just by voice commanding, it can control everything. And it has their own mind, both online and offline, and also it has their own memory. But it cannot remember so many things. Just for something it can remember, and this all about software. Here I used so many software. I made a YouTube video also on it, and today I will upload everything I made. I think this is why this is not working, because I used for that something making for video. That's why some problem coming here. But still I have to work on it. And this is all about my robot. And in my next YouTube video, I will upload everything on it. Thank you.
Okay, thank you very much, Vishal. So now we can have some questions around all the projects. So if anyone has a question, you can either share it on the chat, or just activate his camera and ask.
Okay, ask.
Hello, Vishal. I am curious
Hello,
about.
sir. How are you?
Hello. I am curious about what is your ASR model to detect your voice and then come into the text.
Sir, here I used Whisper for a voice model, and this is my first time for working on this type robot. So I learn so many things, and uh, this all about and what and that's all only. I used here Whisper for a voice model.
Okay, then thank you. And I have a suggestion. Maybe you can try Sense Voice model. Maybe it can have a better
Yes,
performance
sir.
on about your voice.
Yes, sir. I used this just a moment for a voice model. I used this sorry, sir. Currently, I not not remember. And sorry, sir.
Okay.
Can you say
Maybe you
exactly, sir?
can. Yeah,
I have to search on
yeah.
it
Maybe
because
you can.
I used here so many things. So currently, I'm not able to find that and not remembering, recalling also.
Yeah, I think you can also have find this demo in our uh website in our GitHub repo. We have
Yes, sir.
TC. Yes, we have a chatbot example on our D-Robotics organization repo. Yes, you can find it and to improve this demo. I think maybe it can help for you.
Yes, sir. I will improve it. Still, I have to work on it. And this is my first time, so that's why I'm suffering from some problems. And thank you, sir, for helping me too much.
Sim, you also have a question about what was the greatest challenge you have been through during your project?
Sir, I faces so many problems here. First, I connected a phone to RDK X5 to my computer. Here, I use three things. That was sometimes it happen. One if one disconnected, then all my system getting down, not working, and that was the biggest challenge of my project. And for solving this, I used some server flask servers, something like that. And I help I Claude for these problems, and they are also helping me for making this project.
Yeah. Wait. And do you have tried some, for example, import the RDK related skills to the cloud so that cloud can have a better understanding our RDK X5 so that they can solve your hardware or software problem more efficiently?
Sorry, sir, I not proper speaker in not I not listen proper. Sorry, sir.
Uh, I mean, we have a skill about how to use
Yes,
RDK, so I think you can import the skill into the cloud and so that they can better work for you. You know.
I should do that too
Okay,
because
I
I use
understand.
IrisBot a lot.
Yes, I think Simon's question is
I-
also for
Can I give
Rusty friend.
Yeah, so I think the biggest challenge I've had on this is mostly the same challenge I have on a lot of my projects, and that's trying to do too much in too little time. I definitely well, I already had a week-long vacation planned before I found the RDK challenge, and so I was gone for a week and then got home and just been like trying to find time basically. I know that's not a very good answer as far as like technical stuff, but time management is always my greatest challenge.
Yeah, time
Okay, and
management system.
technically speaking, what was your greatest finding on the RDK X5?
I haven't had any really issues with the RDK so far. This was the first project that I've ever wired up a CAN bus for, and had a few issues with that, like trying to figure out the correct topology of the trunks and stubs, and getting the termination resistors only at the ends because the motor drivers I used had them soldered in. So like uh, it was nice that I could just put a jumper on the X5 to have that be terminating one end, but I had to desolder a bunch of little resistors to put all the other ones in my CAN bus. I'm sure I will run into more issues coming up. I guess one issue that I was trying to deal with last night and this morning was figuring out how to tune my motor drivers. So like, I'm using some ODESC motor drivers that are like knockoff older O drive drivers, and they've got a bunch of different modes. And I found that if I put it in like a velocity control mode, the robot basically can't move. It just like can't overcome the static friction. And if you put it in torque control mode, it just goes a million miles an hour and crashes into everything. So, but that's still not an RDK issue. That's a me not understanding my motor drivers issue.
So basically, can you explain more in detail your electronic architecture?
Yeah, so at least let's see. As of my cord, I set my laptop on my cord. That's supposed to be longer. Okay, I'm back. That's not even the right webcam. Let's see, switch to the other one. Here. So at least as of right now, get rid of some of these. I've got an IMU right here going into my X5 and a little portable Wi-Fi router. And then this is my CAN bus wire that goes from an RP20 2350, whatever the newer Picos are, and then goes to all my motor drivers, which are let's see, in here, just knock everything down in the process. So I made this little like kind of acrylic tunnel that has a heat sink on the bottom with the brake resistors on the bottom, and then 4 motor drivers mounted on the side, and then a fan to just push air through this little motor driver tunnel. And then that CAN bus is hooked to each of those in series. And those go to the hoverboard motors. Once I get the drive system all finished, I'm gonna mount. I got one of the D-Robotics stereo cameras that'll get mounted on one end, and then also pull the LiDAR off my old robot, my old broken robot. And it's a 2D LiDAR that I built a spinning stage for so that I can get a spherical scan out of it. And then I had made a big encoder wheel for it, but I'm going to replace that with just a Hall encoder that can feed the rotation angle into the RDK. But other than that, it should be pretty simple. I've got some like addressable LEDs that I want to do some animated eyes on it that take some of the IMU data and can kind of move the eyes around as the robot moves. I haven't figured out exactly how big the eyes are going to be, so I bought some of these addressable circles that you can break out each row, so I can just figure out what size I need and then break off all the ones I don't need. But I basically got it driving yesterday, so I haven't gotten a chance to do all the kind of bells and whistles that are just cool, because I was aiming for at least having it be able to move.
Okay, thank you. And I think it's already 1 hour, and I think it's time to like end this session. And we really thank you for like taking time to either share your projects or listen to the projects. Where challenges, the projects may be on the way, but we are stepping forward, and we truly appreciate your efforts, and we really um, want to see your further progresses and outcomes. So thank you, everyone. I think let's call it a day.